Hey everyone, welcome to SingularityComputers Client Build 8 Part 5. The name of this build is Cytotoxic. At the end of the last video I installed the first of the cables. In this video I'm going to mainly focus on completing both of the water cooling loops. The noise blocker PL2s have now arrived, so I can now install the rest of the fans and radiators. Before I do, I'm going to cover the specifications of all of the fans that I'm using in this build. So the Enermax TB Acrylic, 900 RPM, 63.78 cubic meters per hour, 1.088 millimeters H2O, and 17 decibels. So they're an extremely silent low RPM fan, and some of you might be thinking that they don't really move enough air to be used on a radiator. But to some extent, the larger the radiator capacity, the more silent the fans can be. And I've gone for massive radiator capacity in this build for a number of different reasons, the main one being silence. I've now removed the 24-pin and PCIe power cables and also both of the pumps. I've removed the cables to install the fans onto the mid-plate radiator because they were in the way, and also to test them. It's extremely important to test any custom wiring that you make because it only takes one small mistake and you can end up damaging components. So once I've determined that there's no serious problems, no shorts or anything, which I do with a multimeter and power supply tester, I then hook up the power supply and cables to my test bed and run it for 24 hours under load. I always test all of my critical components before I use them in a client build, so it's also part of that process. Now for the specifications of the Noise Blocker Black Silent Pro PL2s. 1400 RPM, 1.24 millimeters H2O, 56.5 CFM, and 22.5 decibels, so similar noise output to the TB Acrylic. Now the reason I've removed the pumps is so that I can sleeve the pump wiring, because once I get the fans installed onto the mid-plate radiator, there's not going to be enough room. So I've sleeved the wiring in $1 Million PC black, and I'm not actually sure of the cable lengths that I'm going to need yet. I know they're long enough, but I may still need to shorten them later in the build. I've now finished installing the rest of the fans onto the 480mm radiator, which is now ready to be installed, the 360mm radiator on the mid-plate, and also the exhaust fan at the top of the build. And I'm now going to talk about the thermal design that I'm going for in this system, and also the dust filters. The fans on the 480mm radiator, I'm going to have blowing the air across the bottom compartment. The fan on the power supply is going to be taking air from the bottom compartment and out the back. The fans on the 360mm radiator on the mid-plate and also the one in the 5.25 inch bays are going to be taking air from the bottom compartment into the main compartment of the case. And I've had a few people ask me, where do the fans in the 5.25 inch bays get their air from? Those people must have missed the part where I cut a large hole in the mid-plate so that those fans can easily draw air from the bottom compartment, mainly considering that they're low RPM fans, they don't move much air. They can also draw some extra air through the holes in the sides of the 5.25 inch bays. Now some of you might be thinking that's a lot of hot air going into the main compartment of the case, but this is something that you often need to do with water-cooled builds because you need to work with convection and maintain positive pressure inside of your case. Some people get the idea that this is going to have a massive impact on temperatures, that bringing air in through a radiator into the main compartment is going to heat up your components. But the difference it makes is very small as long as you have good ventilation. And the ventilation in the top panel of this case is excellent. There's also an exhaust fan, so all of the hot air is going to rise out through the top panel. There's also going to be massive positive pressure inside of this case, which is excellent for dust prevention. Now in this build there's going to be 8 fans drawing air from the bottom compartment, and also the 4 fans on the 480mm radiator moving air across the bottom compartment. So the best thing to do in this build to prevent dust is obviously to dust filter the entire bottom compartment. So that's something that I'm going to talk more about coming up. I'm now going to go back to work on the water cooling loops, and I'm going to start by completing the graphics card loop. It's time for me to decide whether I'm going to use Bits Power Crystal Link or the EKFC bridge between the graphics card water blocks. I've installed Crystal Link, and I think you can see what I was talking about previously, how many fittings are now needed to create a Crystal Link config with the new EK graphics card water block design. But in my opinion, the only thing taken from the aesthetics of this config is the ends of the FC links. They're really designed to be covered by the FC bridge. So mainly because of the reasons I've mentioned previously, I've decided to stick with the EKFC bridge. I'm now going to take you through a tubing technique that I've seen recently. I'm not sure who came up with it, but it's an excellent idea because I know what turns a lot of people away from building loops out of acrylic tube is the massive amount of fittings that are needed, the expense. And this is a way around that because essentially all you need is a multi-link fitting on either end, as long as you can bend the tubing into position. Now, I'm not going to use it in this build because it doesn't really fit the theme. What you're going to need is some acrylic tube, and just to give you an idea, I picked up some from a local supplier. I got 9 meters for $30, so if you get it from the right place, you can get it very cheap. You're also going to need something to cut it, and I find this handy because you can use it right next to your system. It doesn't make any mess. It also has a blade on the back of it to clean up the inside of the tube, but you can use any cutting power tool, jigsaw, Dremel, even a hacksaw. And once you've made a cut, make sure you clean it up nicely. Clean up the inside and outside of the cut, and you need to round off either end of the tube, otherwise it's going to damage the O-rings in the multi-link fitting. If you take a look at Crystal Link, you'll see that the ends are nicely rounded off, so you're going to need a file to do that. You're also going to need a heat gun or a similar heat source, and you need to heat up a decent sized section, approximately 50 millimeters, so that you don't get any kinks or flat spots. Be careful you don't burn the material. The first sign of burning is bubbles in the material, and even just a couple of bubbles is going to destroy the aesthetics, and it's going to mean you need to start again. So keep the heat source moving at all times, and also rotate the tube so that you heat up the entire section. Keep testing whether it's ready to bend every 20 seconds or so. So, you know, just try to bend it, and you'll know when it's ready to bend. It bends very easy, and it doesn't really take that long to heat up. It took probably a bit less than 60 seconds with this heat gun, and I thought that it would set very quickly, but it doesn't. You don't need to rush. It took about 30 seconds to set for me, and that gives you time to get it inside of your system and, you know, have a look at it, because most of this you're going to have to do by eye. Anyway, I just thought I'd put this information out there. I think this could look amazing in certain systems if done right. I've now installed the 480mm radiator, so all of the fans and radiators are installed. And I think you can see the massive improvement in aesthetics, the black noise blocker PL2s compared to the white noise blocker E-loops. I did actually have a plan for the white fans. They were going to match up with the coolant color I was going to use, but black just looks a whole lot better in this build. I'm also really happy with the way they look on the mid-plate radiator. With all of this black, the water cooling loops are really going to stand out. Okay, I've now completed the graphics loop. I've talked about the fact that I wanted to build both of these loops in parallel, and my thinking was that it was going to fit the theme because it was going to increase the amount of tubing and fittings and the complexity of the loops. But it ends up that I couldn't build the CPU and motherboard loop in parallel because it was going to be too much of a mess, and it was actually, you know, not going to improve the performance. There was going to be no benefits from it. And when it came to building the graphics loop, I had a lot more freedom with different parallel configs because of the two radiators, and it would have actually looked amazing, but I really want these loops to match as much as possible. And they would have looked like two completely different loops. It would have looked really out of place. So I've built both of the loops in series, and what I'm doing to fit the theme, I'm sticking with horizontal and vertical 90-degree angles. My thinking is that it looks like the piping in a nuclear reactor. The only part of the loop where I'm not going to do this is between the water blocks on the motherboard, because they're too close together and it would take a mess of fittings to do it there. Now, because of all the joints in these loops, there's a little bit of movement in them, and it's not really a problem, but I'm actually going to take the opportunity to create another little feature, and I'm going to reinforce the loops at their weakest points. So that's something else that you'll see coming up. Now I still need to talk about these loops in detail, but I'll do that once they're complete. Because I've talked about serial and parallel so much in this build log, coming up I'm going to compare the two, and I'm also going to compare a single loop to multiple loops. So that's coming up in the build log. Okay, I'm now building the rest of the CPU and motherboard loop. I'm building the section that goes from the pump through the midplate down to the 480mm radiator. I get a lot of people asking me to show the process of me building my loops, but in my opinion there's really not a whole lot to see, so usually I don't show much of the process. Most of the thinking comes into it when you are designing your loop, and I do most of that as I go, but when you're modding, when you're doing case mods, you need to have a good idea where everything is going to be, also of your loop design, before you even start the system. But when it comes to the water cooling loop, most of the time it is just a vague idea. The details come later. Now, I get a lot of people asking me for exact lists of the components I've used in certain builds, or just what fittings they're going to need for their build. One of the hardest parts of building a loop from bits power fittings and acrylic tube, or even just doing a crystal link config, is knowing the fittings you are going to need to get the correct angles, heights and lengths. It's all guesswork. It all needs to be done by eye. The only way of vaguely knowing what fittings you are going to need, when you're making an order, is by counting the amount of water cooling components you have and figuring out vaguely the distances between them. Other than that, it's all guesswork, and you just need to order far more fittings than you actually need. Okay, I've now completed both of the loops. When I was designing this build, designing the case mods, I knew that there was going to be a lot of tight angles for the water cooling loops. I also knew that I was going to build both loops entirely from bits power fittings and acrylic tube. And I knew that a massive amount of fittings were going to go into these loops, which is perfect because it fits the theme. I wanted a lot of silver in the build, which is why I've gone for the bits power black sparkle mod kits on the pumps, also the Corsair Dominator Platinum and the EK Supremacy Elite. I would have gone for more silver, but I thought with all of the fittings it should be enough. I still wanted the silver only as an accent. But anyway, what I'm saying is I certainly didn't hold back on the fittings when building these loops. I'm now going to take you through the tubing routings of both of the loops, starting with the graphics loop. So I've dropped straight down from the pump to the mid-plate radiator. And just to give you an idea of how many fittings have gone into these loops, just between those two components I've used 5 90-degree single rotary fittings. Now there was a couple of other ways to do this. I wanted to go between the pump and the fan here, but it wasn't possible because there was no fitting that could get me the right height to get through there. Then I thought maybe I could come out around the outside here, but then the loop would have protruded, it would have been in full view, and yeah, it just would have looked terrible. So I decided to hide it around the back. Now what I've done, wherever the loop is out of sight, or mostly out of sight, both loops, I've used extension fittings because they're obviously far stronger than crystal link, so it's just to give the loop some more strength. Also, you'll see in some areas I've used 90-degree single rotaries, for example here, to get in nice and close to the pump and res config to keep things clean. And then everywhere else where I haven't really had to use 90-degree single rotaries, I've used 90-degree dual rotaries because I prefer the aesthetics of the curves. It also slightly improves flow. And there's also the fact that there is only one 90-degree dual rotary, 90-degree fitting with female threads on either end, which allows you to use multi-link fittings. So you can see what I've done here. I've screwed a multi-link fitting into either end of that 90-degree fitting, which means you can have a 90-degree bend in the middle of a crystal link config, just like that. So then I've come up the other side from the mid-plate radiator with extension fittings, as you can see. I've gone around into the graphics cards. Now the EKFC bridge, this was the only way to configure it. I could have turned it around the other way, and that would actually mean that it would line up with the graphics cards. So it would line up there and also, at the top there. So, the problem then would be that this end would be up here, so I'd be going right out and around. And this also gets me a little bit closer, you know, where it protrudes, so it shortens the tubing routing a little bit. And you know, if I had have turned it around the other way, there wouldn't be the strong division between the two loops, which isn't so visible now, but once the system is up and running, coolant is in the loops, different colored coolant, you're really going to see that strong division and the contrast, that line down the middle. So I've then gone straight through to the radiator in the 5.25 inch bays, and I've used 5 90-degree dual rotaries to get through there. I've then gone straight back into the top of the res, and I had to do this unusual config here because again there was no fittings that would get me into here. And you can see I've used one of the new Bits Power telescopic multi-GPU water cooling fittings there. They're very handy. I wouldn't actually use them for a multi-GPU config, but they're great for building loops from Bits Power fittings. Now, a lot of people ask me where I get these res tubes from. They come with Bits Power tube reservoirs. Every single Bits Power tube res will come with one of those, and for those of you who don't know what it does, it brings the coolant coming back into the res below the level of the coolant in the res. So it stops splashing, stops noise. It also stops air from constantly going back into the loop, which is, bad. It destroys performance and makes the loop very noisy. Now, I've already showed you the fill port up here, so I've used 4 of these fittings in this build, which are designed for basically taking a loop through a panel and out the other side. They're great for fill ports. And up in there I have a 90-degree dual rotary and single rotary, and a extension fitting to get into the res. Now, the drainage system for this loop is down here. Originally I wanted to put it just here, but I didn't want it to protrude. I didn't want it to be visible, I wanted it to be back underneath the pump, but it just didn't fit there. So I've had to put it back here, but it is a great spot for it because it's almost completely hidden, and still all you need to do is screw in a barb fitting and push some tubing onto it and just run it down into a bucket. It's easy. And it's actually on a 90-degree dual rotary fitting, so it can be rotated and moved around a little bit. And my thoughts on drainage systems is you're going to use them once, maybe twice in the lifetime of a build. I usually only use them once to drain the loop, and then I dismantle the system, change it and upgrade it. So why create something incredibly extravagant that is fully visible and ugly when it's hardly ever going to be used? My thoughts are just create something practical and hidden, that's going to work. It doesn't have to be right down at the lowest point either, because when you drain a loop you're going to flush it out anyway. And I've seen even the most extravagant drainage systems are still very difficult to use. Most of the time they don't work properly anyway. Now, for the CPU and motherboard loop, I've dropped down from the pump through the midplate. You can see another couple of those fittings there, down to the 480mm radiator. Now in here I've used another one of the telescopic fittings, and that's the larger one there. I've also used another one just here, and this was difficult in here because very tight angles, and it took me some time to figure out which fittings I was going to use down there. I've then used a Bits Power 5-way multi F block here, and I actually still need to put a stop fitting on the other side of that to create the drainage system. So I have another Bits Power tap here, and again all you'll need to do is connect a barb and some tubing, and of course open the top of the res to drain it out. And there's also a free port at the top of the res on this loop so that you can open the res to let the air in. I've then gone up through the mid plate again and into the chipset water block, then the CPU water block, then the MOSFET water block, and then back to the top of the res. And again, another unusual little config here, which I was actually really happy with. There's an extension fitting, 2 90-degree dual rotaries, a small telescopic fitting, another dual rotary, and a single rotary. And then the fill port, another one of those fittings here. And as I've mentioned previously, to use this you'll just need a 90-degree dual rotary. So both of the loops are very short, and there might be a lot of 90-degree fittings, and I may have used a smaller diameter tube, but with loops this short, you know, with such powerful pumps, there is no way performance is going to be a problem. Anyway, that's both of the loops complete. I'm now going to move on to some more of the wiring. Okay, we've now completed almost all of the wiring. So I've mentioned previously that I have someone working on the wiring with me, and he's just started recently, and he's going to be working on the wiring with me in my builds from now on. And I talked about all of that in the last part of the build log. Previously I showed you the 24-pin motherboard power and also all of the PCIe, of which there's 6x6 pin. Now we have also completed the SATA power, of which there is 2 for the 2 SSDs, and the Rampage 4 Extreme takes an 8-pin EPS and 4-pin ATX, so we've also done both of those. For those of you that missed it, this is all sleeved in $1 Million PC black, and as you can see it's shrinkless. And I'm really happy with all of this wiring. It's going to look amazing in the build, and that is the next step now, to get all of this wiring installed. And after that there's still a fair bit of work to do on the wiring. We need to wire up the pumps, the fans and the lighting, and also there's the SATA data, and all of that is of course going to be custom and sleeved as well, so there's a fair bit of work in it. Anyway, that sums up this part of the build log. Thanks for watching. Please subscribe, like and favorite if you want to see more.